Hello and welcome to this tutorial for nuclear reactor design. In this video we are going to be covering 1D radial heat conduction. Now we are going to be looking at how heat transfers in one dimension from the center of a cylinder outwards. Now we are going to derive the equation for radial heat transfer by considering the energy balance of a thin ring inside of the cylinder, which has an inner and outer radius of r and r plus delta r. The energy balance of this thin ring is equal to the difference in the rate of heat conduction added to the rate of heat generation inside the ring, and that is all equal to the rate of change of energy within the thin ring. Next, we expand the terms for the rate of heat generation and the change in energy content to get this formula here. The next step is to divide the entire formula by A multiplied by delta R, and the formula will look like this. If you take the limit of delta R as it approaches 0, the left-hand side of the equation now can be represented as this. By also taking the limit of delta t as it approaches 0, the term on the right-hand side of the third equation also changes, and their new formula looks like this. After changing the area to be equal to 2 pi times the radius times the length, our formula now looks like this. Now we will simplify the formula for 3 different conditions. The first condition we'll look at is a steady state. The formula will now look like this, with the right-hand side being equal to 0. If the conditions are transient with no heat generation, the second term on the left-hand side becomes equal to 0, and the right-hand side is divided by the thermal diffusivity. The last conditions we will be looking at is steady state with no heat generation. This equation only has the first term of the formula. The rest are equal to 0. Now we will take a look at an example question. There is a horizontal cylinder whose temperature does not vary on the y-axis. The outside of the cylinder is 20 degrees Celsius. The center is 30 degrees Celsius. The cylinder has a radius of 2 meters. We want to find the radius where the temperature is equal to 27 degrees Celsius. To answer this question, we are going to use the third formula because it is at a steady state and there is no heat generation within this cylinder. We can begin to solve this question by integrating the equation with respect to r. Now we are going to integrate with respect to r one more time. Now we have an equation for temperature, but it still has 2 unknown constants. To solve these, we are going to have to look at our boundary conditions. From the information in the question, we know that the temperature at 2 meters is equal to 20 degrees Celsius, and the temperature at 0 meters is equal to 30 degrees Celsius. You can solve for the 2 constants by using substitution. Our full function for how temperature varies along the radius, it is equal to negative 43.28 times the ln of r plus 30. To find out at what radius the temperature is equal to 27, we are going to set this equation equal to 27 and then solve for r. Solving for r, we see that the temperature is equal to 27 degrees Celsius when the radius is 1.07177 meters. This will conclude the tutorial.